So I've just prepped up the stream for YouTube Live, and we should be going live there soon.
If I remember correctly, there's a little bit of a delay with YouTube. Not a huge one, though.
Yes, slight delay. And
Looks like we got a couple early birds streaming in.
yep, love the enthusiasm. Always a planning. I myself. So glad to see some early hands in.
Very cool. Pleasure to see you folks.
Guys, so we'll be going live at the same designated time. That's going to be 5 minutes from now. And probably we'll wait a minute more for some more folks to join in, and then we'll begin. So Chris, while we're at it, how's it going? How are things going? A pretty dope background, by the way. Is that like a collection of trophies, or how's that? How does that work? Very curious.
Well, some of it's my wife's, some of it's mine. Over the years, we've collected all kinds of little figurines and statuettes. Some of them from video games we like. Both my wife and I are cosplayers. We like to dress up and go to conventions. Started as Renaissance fairs for me. Suit of actual metal armor. Yeah,
how heavy
been a lot of fun over the years.
That looks pretty heavy, that armor that you're
talking
about.
God, it is. The shield itself is about 32 pounds.
My goodness.
And then the helmet, the breastplate that's underneath it, you can't see behind the cape, the boots and the gauntlets. I think all together, if I pair it with the chainmail shirt that's out in my garage, it's like 180 pounds. It's really heavy.
I have never lifted that much, and even in my own, even if I go to the gym, I doubt I'd be able to lift that much. But that looks heavy.
I'm a big lad though, so I'm 6'5".
Damn, if you reverse those digits, that's just how tall I am. 5'6" actually.
Yeah, I'm unfortunately, or one way or the other, a big one. So when you're wearing armor like that,
it's a good thing you're meeting my Zoom. I don't want to stand next to you. That's gonna give me a complexion.
Oh, it's okay. I run my head into doors all the time. It's all right. People can ask me how the weather up there is. It's good. But yeah, it took us a long time to collect all this stuff. So the armor I myself made over a long period of time. Most of it, though, just bought and placed on the shelf.
Cool. Awesome. So just some of the interesting stories that you might want to share, which is one of the most memorable trophy out there. And are these like, do you follow a particular genre when it comes to gaming, or how does that work?
Genre-wise, no, not really. I think probably one of my favorites that's actually visible on the screen here, which would be this two right kind of in that general vicinity. They're from a game from PlayStation called Silent Hill, and they're my wife's. Bought those from her, or for her, a couple years back. Very excited when she got them. Watched her get all giddy for several days over them. I think that's probably my favorite. Definitely like seeing her get excited about that kind of stuff. I think probably next would be this shield. My father and I built that probably 10 years ago.
That's
together.
Handmade.
Yep, handmade.
My goodness.
All of the armor is handmade. Even this banner here, that's not cloth, that's actually metal.
Oh.
It's anodized aluminum.
Must have taken quite some time to get that done.
A couple months.
Wow. Some heavy DIY projects there.
Yeah, that one a gentleman friend of mine helped make. I'm gonna leave his name out because I'm not sure he'd be okay with me throwing it around on a webinar. But no, that one I had help. But otherwise, me and my father built the majority of it. So getting to wear it around is pretty fun. The cloth, I do not sew, not to save my life or anybody else's. Friend of ours, she sewed that for me. But we would put our costumes together and then go walk around these conventions. I learned to make the armor when I was 17. Was part of a Renaissance reenactment group. That was pretty fun. Did that for a few years. Got to go sword fighting. That was fun. The bruises weren't fun, but the rest of it was fun. You put on all the armor to protect you, and you go out there, and they teach you how to fight in the different styles from all the different eras. Yep, a lot of cool stuff. A lot of history involved in it. That was actually really fun.
Awesome. So I've been a fellow cosplayer myself, but I'm not into. I'm not a gaming cosplayer, and it's not. I don't have as heavy a collection of yours, but I usually cosplay for anime. So basically, I'm an anime character cosplayer.
So do I. It's where I met my wife.
Wow, that must have been interesting.
We were originally both anime cosplayers.
Interesting. Interesting.
We actually were staff for a convention for, oh God, I think I was staff for 10 years and she was staff for, I'm probably wrong here, but at least 5, if not 6. She headed up photography, and I headed up live action role play. I would help people do like cosplay chess or rock, paper, scissors gaming, non-contact stuff.
Wow.
Where actually we started. I did a lot of cosplay from a video game and tabletop miniature game called Warhammer 40K. Did a lot from that. Cosplay from Final Fantasy games. That was kind of fun. The only stuff of mine that's actually quality, though, would be the suit armor behind me. That's from Warhammer 40K.
That looks quality.
Technically, it's from Warhammer Fantasy, but you can use it either or.
So we see that there are more hands showing up, and we are on about time, and so we'll just wait for 1 more minute, and then we'll get started, guys. Thanks for tuning in. While we wait for another minute for a few more folks to show up, how about you let us know where you're all tuning in from? I'm from Delhi, India. Chris, how about you?
Cedar Rapids, Iowa.
Let us know in the chat, Zoom chat, guys, where you all are tuning from, and we'd love to know. So probably, Chris, I'll get one-on-one with you later on, and I'll be getting some anime discussions in, and probably take some tips on the cosplaying thing as well.
Sounds good, man.
Yeah. So we have
Hyderabad.
Yeah, that's Balakrishna from Hyderabad, India. Amneet from Punjab, India. David from Jacksonville, Florida. Hey everyone. Olena from Ukraine. Salim from Delhi, India. So we're getting hands across the globe, it seems.
Yeah, very
showing
cool.
Up from different places. So Chris from Massachusetts, Gabriella from Boston, USA. Welcome to this event, everyone.
Welcome, folks.
Perfect. So we are 2 minutes up the designation time, and I think this is about a good time for us to start. Hey everyone, thanks for tuning in, and let me start the screen sharing and get this show started. All right, Chris, could you confirm if my screen is visible?
And can see it.
Awesome. So everyone, good morning, good afternoon, and good evening to you from wherever you're tuning in from, and welcome to LambdaTest webinar. And in this webinar, we're going to be talking about something which has been common throughout, something that pretty much enterprise and small businesses alike are chasing with a constant requirement, that is agility, how to ship things faster, how to move test velocity up a notch and increase your go-to-market pace, how you can evolve your test cycles, and what minor tweaks you can do in order to enhance the overall acceleration of your delivery pipeline. And I have with me none other than Chris Wallander, who has been a principal SDET test automation architect at TaxAct. And I am Harshit Paul, product and growth manager at LambdaTest. Chris, the next slides are up to you. Please feel free to introduce yourself to the audience.
Sounds good. As you just said, my name is Chris Wallander. I've been roaming around the QA industry for a little over 13 years, all things considered. About 10 of it's been with test automation, and about another 5 of it's been in DevOps. You can go ahead and jump to the next slide.
Sure.
And you guys are kind of hearing a little bit about us beforehand. Outside of work, I'm in video game design, development, testing, machine learning, artificial intelligence. I build drones, I build robots, and finally, I do medieval armor and cosplay. All kinds of fun stuff.
That sounds impressive. So before we get into today's agenda, I just want to take up and take care of a few housekeeping items. This webinar is going to be an hour long. So in case you have any questions while we are going through the entire webinar, feel free to drop them in the chat, and we'll be taking that up towards the end of the webinar, where we will have a dedicated Q&A round. In case you're not able to stay with us for an hour, you have something to attend to, don't worry about it. This webinar, the full recording of this webinar will be shared with you on your registered email address. And you can also find this recording over our YouTube channel. So in case you're not already subscribed to LambdaTest YouTube channel, go ahead, search for it and subscribe it. We share a lot of insightful content and best practices around optimizing automation testing in general, or getting started guides around particular frameworks, CI/CD, and etc. So by all means, go ahead and check the YouTube channel in case you have not already. And having said that, let's get into today's agenda. What we'll be basically touching upon are going to be these pointers: code level acceleration, what you should be doing, what you should be avoiding, how you can use APIs to set up test data in your applications, importance of automation pyramid, risk-based testing, CI/CD in general, and then towards the end, I will be taking up a LambdaTest demo with you guys, where I'll go ahead and dive into the platform and talk about the capabilities of what you can do with the LambdaTest. So having said that, that is the cue from me. Chris, I'll pass the mic to you, and I'll stop sharing now, so you can go ahead and get into the show. Yeah.
Sounds good. Let me get my slides set up here real quick. That way folks can see it. And we should be seeing some slides.
Yes, we can.
Perfect. All right, and just as kind of a reminder for folks, feel free to ask questions in the chat as we go. At the very, very end, we will be sitting down, going over a good number of those together. And then Harshit, for you, feel free to jump in whenever you have questions as we're going. Obviously, there's going to be some things in here that are worth talking through a little deeper, and I welcome you to do so.
Definitely, I'll do my best, yeah.
Alrighty, guys. Today we're going to be going through a large topic set, enterprise acceleration. Before we even start talking about automation itself, though, when we think of enterprise as a whole, let's tackle the foundation. Some things I want to talk through today. Really, what is an enterprise, right? We're going to start with the basics. What are some common areas automation can help? And then finally, what are some practices for improved speed? That's kind of what most of us are here for today. Enterprise itself has a few different definitions. Merriam-Webster's just says it's a unit of economic organization. Sounds a bit lacking. Really, it's a collaborative mixture of all the different groups in your company working together to complete a goal. And as you can see here, depending on your company, there may be a lot of different groups. As part of this overall goal, which in our case is going to be the delivery of software, we have the software development lifecycle. There are many different models of the lifecycle, and for today, we're going to be staying a little generic. Each model shares some common phases: requirements, design, implementation, testing, deployment, and maintenance. For it all starts again on a new development cycle. The focus of today is on how we in quality assurance can speed this up. Foundationally, we are coming into this talk with the assumption that requirements are well-defined and communicated. Without good requirements, each phase afterwards struggles in a cascading domino effect. This comes to our main question. It's quality assurance. How can I speed the lifecycle up? Some common items people normally associate with lifecycle acceleration are continuous integration, continuous delivery, and finally, continuous deployment. These are all forms of process automation that fundamentally rely on test automation. Continuous integration seeks to do several things here. First, we want to prove that the code has as few bugs as possible before we even deploy our code to a testing environment, even our local machines. This is done by having a high degree of unit testing in our application, something that may not be done by QA in your organization. If it is not, you would want to be talking with your developers to see what kind of tests they can be including. We want to see code changes to the application be small but still viable, passing these unit tests to allow any kind of code merge. Finally, this is where your process automation would normally perform all of this when you do any kind of code check-in or pull request and be a gating mechanism. The idea in unit testing is that it is the quickest to write and easiest to maintain test automation type you can perform. Defects found or more importantly prevented by unit tests are also the cheapest defects to repair. We'll be getting more into that later. Continuous delivery takes what we just discussed from continuous integration, builds onto it. Say your developer just successfully performed his pull request and the application code is now sitting in a mainline branch somewhere waiting to be deployed to the testing environment. Continuous delivery would use process automation to automatically deploy this code to the testing environment and then trigger any selected regression test automation to validate that code change is non-breaking. Should the regression suite fully succeed, the deployment artifact would be marked ready for release. This would allow the team to perform any additional tests they require or complete any compliance work they may need to do. Continuous deployment is the final stage as defined today. It takes what we just discussed and goes one step further, releasing the change to actual production. Slow sounds good on paper, but requires a very strong commitment from not just the team, but the organization itself in order to accomplish. Typically, this is not something I would recommend to most organizations until a certain maturation happens in their business. Typically, this is based around compliance testing, or sometimes you might have some kind of change advisory board you have to meet to before any kind of code can go out. While a lot of that can be automated, again, takes that maturation in the business. All right, now we covered continuous integration, delivery, and deployment. Let's talk about powering it all with tests. Even when we have successfully automated most of our test cases, we very likely will have too many of them to run on every single change. This brings us back to a foundational question in testing. Which tests are the right tests for the time I have available? We're going to answer that today with risk-based testing. In risk-based testing, we know we are not going to be able to execute 100% of our tests, not unless we have unlimited time and an unlimited budget. In risk-based testing, we cover the needs of not only our external customers, but development and immediate system dependencies when choosing our automation to execute in our pipelines. With these pipeline executions, early on, we might be able to maybe execute all of our test scripts, but that's going to quickly change. When it does, we need a strategy in place to determine what goes into the pipelines and what does not. This is usually done through the identification of application risks and the creation of risk levels that you may assign to your test cases for pipeline filtering. There are multiple ways to perform risk-based testing, especially the selection. Here we're going to cover a more visual example, a test priority grid. First, discuss with your team, what is the likelihood of failure for this particular testing scenario? This can be done via standard conversation, maybe even through email polling. How you approach the conversation will, of course, depend on your SDLC. What's important here is the conversation and the understanding that comes from it.
Yes, that looks impressive, actually, Chris. Go on.
Secondly, what is the impact of this failure? As your team evaluates the test cases, you will find that each one falls into the 9 yellow squares somewhere. Depending on which square your test falls into will determine its priority rating, 1 through 5. Test rating 1 will be the first to be executed as the most critical, with 5 being the least critical. During continuous delivery, you may end up only running a subset of all 5 ranks. Typically, it's whatever you can get accomplished in 8 minutes or less of testing time during that pipeline execution. It's a very common practice during continuous delivery to plug these execution gaps with different degrees of scheduled test execution, exercising the remaining tests. This means, for example, you may run priorities 1 and 2 during your continuous delivery pipeline executions, but maybe leaving 3, 4, and 5 to a daily or even nightly scheduled execution. The priority is a powerful tool, but even it has its dependency on test code level acceleration. After all, you can't run them all in 8 minutes or less if an individual test takes longer than 8 minutes.
This actually looks impressive because I was just noticing the priority grid here, and I happened to come across, an article recently, and that actually reminds me of an article which we also have on one of our blogs, which talks about, how you can prioritize browser testing, because that, as a matter of fact, is so varied, because you have so many browser systems and browsers and operating systems in general out there, that without prioritization, you're more or less, likely to roam in the dark, right? It's like,
oh, absolutely,
you wouldn't know which ones you need to prioritize and which ones not to. So a good way to go about that is, just as a matter of fact, just to summarize this, you can have a look at your web analytics and figure out, which browsers and operating systems are bringing you the most number of traffic, and probably create a, similar priority based browser compatibility matrix, which can help you align your CI/CD tools, test suites, and your automation tests, deciding which particular configurations they should be triggered upon based upon their priority. So you can figure that out. And that's just a random thought that came while you were strolling through this slides. Yeah.
And to kind of expand on that a little more, it definitely requires that you have a legacy web-based app in advance to collect that analytics. There are situations where you don't have that available. You might be having a completely greenfield application. When that happens, you can actually go out and look at the market analytics to see, in kind of a rough idea for your demographics, who are the people we're actually targeting and what are they actually using out there? Not only are you going to have browsers, you're going to have cross devices as well. Windows 11 is pretty hot right now and coming out. Same with Windows 10. A lot of people don't want to update yet. Mobile is still the huge winner. So that's all good things to find out and consider as part of this failure matrix.
In fact, that, as a matter of fact, Chris, also happened to be a chart where you can rely on browser market shares, basically. There are sites like GStat Counter, which can help you provide browser and operating system market share, which can give you a generic idea on the trend that is going on in order to give you an assumption as to where to start off if you're just about to launch your application. Speaking of which, I just happened to remember when Microsoft Edge rolled out its Chromium-based browser, right? When they updated their browser and released a Chromium-based version, it happened to skyrocket browser market share and, ended up topping even Firefox and Safari for a couple months at least.
Absolutely.
I mean, and if for businesses who were about to just roll out their applications during that particular tenure, it would be a pity if they would not keep Microsoft Edge, thinking that it's a legacy browser, as a part of their testing, because they might not be expecting for it to climb up the ranks that soon. But if they were, I mean, that's perfect. But if they wouldn't, that's going to be sad for them, actually.
Yeah, and that's always a really good thing to keep in mind too. New devices, fast adopters. Say a new iPhone comes out. It's also good to keep a good eye on what those market changes incoming is going to be. I know just recently we just updated to a new version of Google Chrome. Google Chrome's a forced update.
And that happens so often, really. I mean, what we have like around 100 versions of Google Chrome in itself. I mean, how vast can testing scope can be if we were to cover all of them, for instance?
See, that would also be a real good example, even with the priority grid, even with the cross-browser grid. What's the risk of failure when that update happens? Well, JavaScript might have changed. If it does, check the release notes. You can sit there and go, oh, this is probably pretty high risk. We might want to move it up. Put it on your cross-browser, put it on your priority grid, converse it with your team, get it covered.
Yep. And I will just go ahead and share that blog, which I was referencing to. So in case, our audience can have a look and figure out which, in case you guys want to go ahead and want to devise a browser compatibility matrix, by all means, follow this blog and it will probably help you get started with that.
Perfect.
I'm sorry for barging in, Chris. Go ahead.
No, please. I invited you to.
Thanks. Go ahead.
All right, jumping a little bit forward, let's actually start talking about code level acceleration. This is, one of the big things with test automation. The code itself, I think everyone in the industry at this point, you've heard of the test automation pyramid or some variation of it. Today, however, we're going to look at some real basic variations and talk about some good and bad. All right, before we talk through these three, let's talk about what they actually represent. The test automation pyramid was invented as a rough guideline of the distribution of your testing effort based on the ease of automation and maintainability of the test script. So think about your return on investment here. It's not perfect by any means. But as a guideline, it's an okay starting point so long as we know that it is entirely going to depend on our application or system under test, work processes, or even current testing strategy. The purpose of these is to take your physical counts of tests to look for potential issues. Some people add more onto this base design, also showing manual tests or breaking test types down further into component or integration level tests. None of these are a wrong answer. Use what works best for you and your organization and processes.
Yes, and I believe there's a lot of debated topics around this pyramid as well. A lot of people question about its authenticity. Should we even be following this? Because to be honest, this is something which has been in textbooks from decades now, right? And it looks archaic, but as you said, like the purpose is to set up the foundation and then add onto it based upon what your requirements are. Entirely differs from your project, right?
Now, one picture I didn't put up here is a newer pyramid that they actually put out. I was reading this article probably 3 or 4 days ago. It was based on microservices. It almost looked like an upside down urn. It started real wide, kind of cinched real close, and then bottomed out. It all depends on what you're building, right? It's about optimizing your return on investment. So the first pyramid here, obviously in the upper left-hand corner is our standard pyramid. Basically, you have a lot of unit tests, a little less API service tests, and finally a limited subset of GUI tests. The idea in this pyramid, your effort is to spend more time preventing your defects at the unit testing level, where they are cheaper, more cost-effective to handle, than waiting to catch them at the API or GUI level. Depending on your application, team maturation, and or understanding of testing processes, you may not have this kind of pyramid, may not even be achievable for you. The second pyramid, or test automation ice cream cone as they like to call it, is supposed to represent a company that has little to no unit tests, some API tests, and then a lot of GUI automation, right? This could have happened for any number of reasons. Maybe a legacy application that is so old, unit testing may be extremely difficult to do. Maybe it wasn't a thought when they started. Maybe GUI tests were just an immediate mediation they threw in. Happens. While this can work in a super short term, if the application is readily changing, right, the maintenance effort on those GUI tests is going to be extreme unless a lot of really good practices were followed. This pyramid is typically used as an example of a bad time. High return on investment, high maintainability. And when I say high return on investment, I don't mean the good kind. I mean the really slow, not so good type. Last but not least, here we have a column. It just means you have an equal number of tests between all 3 layers. Again, not necessarily a bad thing depending on your circumstance, but could serve as a warning for future maintenance or other problems in your tests themselves. This is usually a transition phase, probably between the two. As companies begin understanding the value of having more one than the other. Now, obviously, if you look at your own tests, they may not align to any of these. That's okay. You could have any sort of shape. These are just extreme level guidelines of ideal scenarios towards your return on investment. For the purpose of enterprise acceleration, the standard pyramid shape in the upper left there is by far the fastest with the best return on investment. This is due to tailoring the test counts based on their execution speed and ease of maintenance. Now, like we were saying before, this pyramid does not represent your entire testing effort, just the effort of your test automation. Now, we were talking about that ice cream cone. Sometimes you have a ton of UI tests, right? I think most companies are in some kind of transitional phase. You're going to have your scenarios where the app was built 5 years ago, 6 years ago. Maybe it wasn't built with best practices in mind. That's okay. You got to start somewhere. Now, this could be your UI test, either strategy, application, something you just can't get away from. How do we speed that up without losing ourselves to maintenance efforts? Well, it requires an extreme amount of effort and bringing together a lot of different techniques and sometimes even people to accomplish. Ultimately, when we talk about acceleration, unit tests are the fastest to execute, followed by API, and then bringing up the rear is UI automation. Unit and API are fundamentally fast. We don't really need a lot of crazy techniques to speed them up, but UI is not. So we're going to be spending a lot of time today discussing UI acceleration. GUI tests rely heavily on element locators. When we talk about selectors, we mean how we are searching for these elements. ID here is the fastest command, but requires that your application have unique, static, non-changing IDs on their elements. This is a best practice for automation in most scenarios, as it allows development teams to easily reorganize a page without breaking the scripts. That means you might have an ID for a username, and they come in and say, hey, I want to move this a little bit on the page. There's no relatives, there's no pathing, they can move it. Your test doesn't break, you don't have to maintain it. Next up is the name attribute. Some apps don't use these at all. Some don't have IDs but have these. If you don't have IDs but have these, they are static and unique, then they're your second best option. They're still optimized through Selenium. They're very quick. CSS selectors are faster than XPath, but not as fast as ID or names. But they are nowhere near as flexible as XPath, and we saved XPath for last year. XPath is by far the most selectable or most flexible type, but it is by far the slowest. While these allow you to be very creative in your element location strategies, these can also be extremely brittle depending on how they're implemented. That means they can break anytime a developer changes the layout of their application. While this may allow you to start coding faster, getting to start sooner often does not mean the quickest execution time or the most maintainable. Typically, XPath is used only if none of the other options are available.
This actually looks interesting because, as you said, like XPath gives the best flexibility out there, but and that is precisely the reason why I particularly found, in community discussions as well, that people rely heavily on XPath. And it's interesting to see that you've recommended that on as your fourth recommendation and put across ID as first, because I believe as a lot of, enterprise, as a company-wide practices, IDs are usually IDs and names. They're not as well established out there. And that's why people thought that since XPath is flexible, let's just take that from the very beginning. But later down the road, when they realize, which they should realize that, or if they're not, they might realize now that ID and name are the fastest way out. This actually puts up a very interesting pointer, Chris. I wanted to address that the new Selenium has also brought in a locator, which is relative locator, right? Mm-hmm. So what are your thoughts about that in terms of pace and agility, and how does that fit in?
So a relative locator, and there's a couple different ones for Selenium 4, is a reinvention of an XPath locator type that already existed: relative, sibling, child, parent, child. What Selenium basically did, and this was a good thing, is they took that XPath and migrated it over to a JavaScript command, made it faster than the XPath, gave the flexibility that the XPath had, but just optimized it. There's a problem though, and it may not be a problem for everybody, but it depends on how often your application's updated. Anytime you have a parent-child relationship, you're not actually looking for the element, you're looking for something above it and then trying to find it beneath it. If a UI UX designer comes in or another developer comes in and breaks that separation, you still have brittle automation at that stage. They can't just move it anywhere they want on the page. They now have to combine those two objects together, hope they stay as a web component, and then move that web component as a group. So if you have good communication and you know what's going to be happening with your application, they're a significant improvement over the XPath variant.
Got it. And thanks so much for answering that for me, Chris. That was a question from my end. Cool. Speaking of questions, by all means, guys, if you have any questions, feel free to drop them in the chat. Don't stick to the end of this session. Share your thoughts across now, and we'll be taking that up towards the end. Don't let them slip out of your heads. Go ahead, Chris. Yeah.
All right, next up, I think everybody here has at some point heard of explicit, implicit, or even fluent waits while working with Selenium. But just in case, a high-level explanation. An explicit wait is telling your script to wait 5 seconds no matter what. Really, 5 could be 10, 15, whatever. An implicit wait is telling your script to wait until either an element shows up or until a certain time frame has passed, say 8 seconds. Once that time is up, throw an exception and fail the test. Fluent is almost identical to explicit, but we can control the frequency of the attempt to find the element. For example, only checking once every 4 seconds instead of checking once every 500 milliseconds. Right now, as testers, we want to avoid explicit waits. This is due to the scenario where your app could load quickly and you will still keep waiting, ballooning your execution time for no reason. Most wait scenarios in Selenium are going to be using our implicit waits there, with a couple of very specific application needs leaning towards fluent. I can think of a couple scenarios off the top of my head where maybe you have a dynamic table that's loading, but it's only going to load under a certain time frame by design, or you're waiting until somebody interacts with a page in a certain way. Typically, people will start with implicit and then, as needs deemed necessary, add a fluent. Next, a simple one, and I'm not sure everybody considers this one. JavaScript page completion checks. Typically, when Selenium navigates to a page, it will not pause to verify that the page is successfully loaded. It will not pause anyway. So if you immediately try and click on something, the page may still be trying to load and you'll get your execution. Exception. This is where a lot of Selenium flakiness comes from. People will try to interact with something and the page is still loading, and you'll get back your, I can't find the element, it's being intercepted, something along those lines. One easy practice is to verify that the page is done loading before you try and interact with it. It doesn't work with all applications, but may work well for yours. This would be something you could do with Selenium's JavaScript executor against the page. It's just simply using JavaScript to verify that the page is finished loading. If you have a JavaScript heavy application, this is a pretty good practice for you. If you don't have a lot of JavaScript, it may not. Works great in tandem with Selenium's implicit waits. Selenium is pretty quick on its own, but in heavy interaction, GUI tests with lots of page loads, lots of typing, tends to slow down, tends to not be as quick as we feel it should. The concept in JavaScript navigation depends entirely upon your application, so take it with a grain of salt. Say you have a JavaScript application with minimal API support behind it. It's a legacy app, right? The concept here would be to work with your developers to create hooks you can leverage with JavaScript to bypass pieces of the GUI you are not actively using, functionally allowing you to jump around your application. This alone can save literally thousands of hours of test execution time over the course of a year. To be clear, this is a test data setup, speed, and maintainability enhancement separate and before we consider parallelization. Wow. I know some people like numbers, so some fun math for those that enjoy it on a per test case savings. Say you have a singular case with 20 operating system / browser combinations you may test, right? It's a little extreme, but say across that you have 5 mobile responsive views, viewports you got to hit. On average, you're looking at about 5 hours saved per test execution every time you do a full testing pass. Now, keep in mind, we are not talking about parallelization. We're just talking the time needed to be spent across browser tests for this one test case. You start at 8.5 hours-ish. You save 5 hours per. Again, it's not going to work for everybody, but it's about the idea of atomic testing. I'm breaking the test case down. I'm keeping the tests as small as possible and kind of going through those routes. All right, the big one's parallelization. Next up, and in fact, probably the most important, is parallelization. How you do this depends entirely on the coding language and tools you use. Depending on your business, this may look like a Selenium Grid implementation, or even partnering with a cloud-based software as a solution company that specializes in test automation parallelization. When we talk about this concept, we need to understand that it is entirely possible to do it poorly. It costs us more than it saves us. Many people, when they start thinking about parallelization, believe they can take their long-running automated tests, their tests that share data, their tests that depend on each other, and just throw them in the proverbial pot together and hope for the best. In order for parallelization to succeed, your test scripts need to be doing a few different things. First is the tests need to be small, meaning as short and to the point as possible. We talked through a few strategies already in order to do that. JavaScript navigation being a prime example of that, bypassing parts of the application you don't need. A little bit later, we're going to talk about APIs to kind of help do that as well. Typically, a good test when executed on your local machine takes less than 2 minutes to run. Typically, when you're working with a cloud-based deal, you have a little bit of additional time because you're transmitting through the web. But your goal when you're looking at these small tests is 2 minutes or less. Second, the tests need to be autonomous, to be entirely self-sufficient. This means it handles its own test data setup, does not rely on the outcome of a different test in any way, and does not impact any other tested execution time or by altering the state of the application. So that means if you have a test today that is dependent on the outcome and got to be run in a specific order, not a good fit. If you have a test that's altering the state of your database to the point it impacts a second user in your shopping cart, also not a good fit. Finally, a test needs to be atomic, broken down to its smallest irreducible unit. This means that while a normal person might walk through the application examining multiple things one after another, the test does not. It is there to do one highly specific thing, and that one thing only. That might mean you have one test just to check that an error message pops up, but you're not looking at anything else. Next test might say, hey, I can only enter so many characters into this field. Final test is doing something entirely different. The goal with these is that you have a ton of very, very small, easy to jam out tests that create a heat map across your application. You build the infrastructure ahead of time with abstractions in your code. These might look like modules in certain applications, depending on like a software as a solution you might be using. Something where you can keep heavily reusing that automation script to rapidly populate things. Using all three of these in tandem allows modern parallelization tools to grab all of your tests, deal them out to test agents in any order, and then extremely rapidly iterate through your scenarios. Building on our previous example of savings, we had 100 executions we had to do in order to complete our cross-browser testing, which with each of these tests now running 2 minutes apiece, that's around 2 hours and 20 minutes to do the singular execution. 2 hours, 20 minutes, sorry. Let's say we split that up over 5 virtual machines. That 2-hour test pass is now down in a very cool 20 minutes. If your team needs to execute this test once a day, every business day, you're gonna save a lot of minutes here. Looks like around 31,000.
Wow,
that's
probably gonna be
a
my
lot of
favorite
hours.
Slide. Probably my favorite slide.
Yeah, it's a lot.
So how many hours would that be? Okay, if you could help my maths there.
You know, off the top of my head, which involves a calculator, mind you, that would be about 519 hours it would save across an entire year for one test case.
One test case. And imagine having hundreds of them in your regression suite or in general in a new sprint set for all together.
Ultimately, the goal with automation is to try to run as many of these tests as you can, because it goes back to that you can't run them all. You're not going to have time as your business grows. You know, that's when they start getting into that risk-based testing, the selection of the cross-browser and cross-devices. This allows you to get more done. You code your test up in a very specific way so it can run across all of these, and then you let the tool spread and deal them out, handle the parallelization, and then, you know, you're saving 500 some hours per test case. And goodness sake, say you are a larger enterprise organization, you might have tens, if not hundreds of thousands of test cases that you may eventually have to run. It really opens up the amount you can get done in the time you have given.
That's some pretty dope calculation done there. Hats off to that slide in particular.
All right, so let's keep building on this. So JavaScript GUI controls, right? If you are not actively testing the fields you're entering data into, it's recommended you don't even use Selenium for it. This is going to speed you up pretty heavily. You use JavaScript to populate the fields rather than using your Selenium.send keys. Typically, Selenium send keys does type into the elements similar to a real human, but it takes time to do so. Watching one character at a time enter into a field is unfortunately not as fast as simply setting the value of the text box to what you need it to be. I would not use this for testing feature functionality, however, as this does not trigger any kind of on-key press events that may be on a field. Newer technologies like Vue.js, for instance, have a lot of key events. Setting the JavaScript field will not trigger those. This methodology can also be applied to clicking buttons, setting dropdowns, or any kind of browser-side control you're currently not testing. This specific technique is often the first most people consider when trying to speed up their GUI automation. It's really good if you have a JavaScript-heavy app. Next step in speediness is bypassing the UI altogether when considering the setup of your test data. This, of course, depends entirely on your application. Should your application have fully functional APIs? This could mean REST, this could mean ASP calls, anything that can function as an API. You can always use these to set up the state of your application rather than fully walking through the UI to do so. This can save multiple minutes per test, and if used in conjunction with JavaScript navigation, can make a 30-minute test into a 1 or 2 minute test. Using this route can allow you to set up your test with the API, then directly jump to the page in your application with the JavaScript you are seeing to test before performing your assertion. There are, of course, pros and cons. The pro is that the tests can execute many times faster with greater stability. You know, somebody moves something on the page, you don't have to worry about it. You're not using it. However, the tests themselves, upon initial setup, are more complex and require the tester to know about both API testing and UI testing, as well as the subject matter expertise of how the application interacts with its backend APIs. It's also possible an API you need may not be readily accessible in your testing environment. This route also means your test automation framework is extensible, meaning it can be upgraded to handle Selenium as well as make API calls. Some off-the-shelf tools allow this by default. If not, and you have a homegrown framework, you would need to enable both to happen simultaneously within your framework, and then leveraging Selenium to change your browser state. This is typically in the form of adding cookies to the browser and then refreshing the page. Service virtualization takes care of that missing or inaccessible API. Service virtualization is the concept of a fake service that intercepts specific calls made by your application and responds with information you specifically tell it to in advance. Using one of these tools allows you to not need that third-party API or even to inject data into your database for testing. It requires you, however, to have a very strong grasp of all of your application's dependencies and requirements, as you will be setting those business requirements up inside of the service virtualization tool itself to emulate what the downstream application or API would respond with. This allows your executions to go in at just an absolutely blazing speed when combined with some of the other things we've discussed. Even removes many upstream test data setup dependencies. Want a specific user set up in your application with specific data already entered? The tool can emulate the database and say that information is already present. No need for the test to set it up in advance. A trend you may be seeing over the past few items is that the test script design can play an incredibly significant role in the speed of execution. This upfront planning and designing is all about creating the infrastructure in order to go faster. This does not mean that going faster overall means it is faster or easier to implement. It does mean, however, that through planning with your team and implementing a strategy, you can enable your tests and ultimately your software delivery to go faster. Your tests today may not hit some of these items we talked about, and that's okay. If you're already mid-project, it may be too late to add more work to change what already exists, but it may not be too late to change what you're going to do going forward. These are all strategies that can be partially implemented and then built upon, but I would not implement them on your own. Make sure your team has your buy-in, make sure your team is appropriately planning, and then grow it naturally. That's my wrap up. Back to you, Harshit.
Thank you so much, Chris, for all the insights. I happen to love how you summed up from A to Z entirely. We started off with basics of test pyramid, and even before that, you talked about SDLC and generic, and we talked about, and you touched upon so many aspects at the same time, given the time frame. It's just mind-blowing for me. And having said that, let me share my screen as well, because this is demo time where I will be taking up LambdaTest in practice. So this is what the platform would look like, especially the automation side of it. And before we get on to that, let me get onto my slides and talk about what it is that LambdaTest stands for. So at LambdaTest, we basically are providing you a test execution infrastructure, a platform that helps you to execute your tests entirely on cloud, and giving you that hassle-free experience of not indulging into setting up your own in-house infrastructure or figuring out about how much time and bandwidth it's going to take in general to set this entire thing up. What we have right now at LambdaTest is these are basically our broad offerings. We offer live testing, which is a basic manual testing way for you to go ahead and deep dive into an app in your website or web application and interact with that on real time. So you can open from 3,000 plus browsers and figure out browsers and OS combinations and spin up your website or web application across any of them. I'll deep dive more about it once we get into the platform. We also have an automation testing cloud, which basically allows you to go ahead and plug your automation scripts, as Chris also pointed out earlier, like you have it on your local system. That will take around a couple minutes, and you also rely on cloud-based providers. That's where LambdaTest comes into picture. And we also have a real device cloud for folks who want to go ahead and check their application testing, perform mobile app testing. And we have a very unique offering, which we have rolled out recently, which we refer to as HyperExecute. And this is the most interesting part, which I wanted to talk about while Chris was presenting as well, but I'll get to it now. So as Chris pointed out that, while you're running your scripts on local machine, it might take a couple minutes. That's the standard time. But if you're running it on a cloud-based provider, or if you're relying on any of those, there's going to be a factor of latency which might come into picture, right? Because you're sending some commands to the cloud, they're going to different data centers, geographies, and then the result is getting back to you. And all of this could take a considerable amount of time and can extend your 2-minute test execution time to maybe 3 or 4, right? So that's where HyperExecute comes into the picture. It is an entirely cloud-based offering, which helps you perform testing on cloud with test execution speeds similar to what you experience on your local machines. Having said that, these are all the automation frameworks that we support of. When we talk about Selenium, we are basically supporting every framework and language that Selenium is compatible with. That be it TestNG from Java or any Python-based framework, PyUnit, PyTest, anything, you name it, we have it. Then we have 3,000 plus browsers and OS combinations on board to help you with your browser compatibility matrix in case you have one in place. And we have 1 million plus users who trust LambdaTest for their testing needs. 100 plus product integrations with third-party applications that to help you accelerate faster. I'll talk about these integrations as we get into the dashboard, but and probably in the next slide as well. I'll wait for that. So 24/7 technical support in case you get stuck at any point of time. We would love to help you, be it around the product onboarding or any technical challenge that you're facing while triggering your scripts or anything altogether. What's best is you get lifetime product free access to the product. So go ahead, sign up with LambdaTest in case you haven't already and figure it out for yourself. So this is what the integration landscape looks like. As I said, we have integration across board with different types of different types of tools, be it project management, be it bug tracking, instant communication, CI/CD, codeless automation tools, test reporting, etc. So having said that, let me get into the platform and talk about how it works in general. So this is what the platform looks like once you log in. And before we get into these logs, the first part is how about you, what effort it will take for you to execute your local scripts on the LambdaTest cloud, right? And the changes for that would be very minimal. So you have a code to yourself. And within that code, you need to specify your LambdaTest username, your LambdaTest access key, which will set up a remote WebDriver path, basically, and LambdaTest hub URL. That way, you're able to authenticate your local test to LambdaTest cloud-based grid. And you can get these very easily from the dashboard itself, right, by using this button, which is highlighted as the access key on the dashboard. You can get these 3 things and plug them into your test scripts. Next part comes about the configurations over which you would want to run these tests. And that's where, for example, I'm running this test over. So browsers, right? And that's where our capability generator comes into the picture, which you can access from here. And this way you don't need to sit out and code by yourself. You can figure out which particular operating system you wish to run your automation test upon, and you can get those values changed on the code for different set of languages based upon your selections. There are also some advanced configurations, for example, geolocation testing, which will allow you to test from different IPs in case you have a test case that you would want to test from different locations. You can capture network logs and a lot of extra details on the dashboard by playing with these toggles. You can also capture command by command screenshots in case you turn this toggle on and pass this capability as true in your code base. So having said that, I have this code with me, and let me try to run this on the platform. So yeah, we are initiating tests, and as I go on to the platform, let me reload the UI, and I see that there is, all right, I hit the reload button, but so I see that 2 test cases are running in parallel right now, which is the similar thing that we are running over here. And 2 tests have passed. So my parallel counter is reflecting that 2 tests were in my parallel queue. And this is what I wanted to touch upon. Chris has already set up a base for me while he was presenting this. That parallelization is basically the key for you to accelerate faster, right? The more you're able to, especially if you're scaling, right? If you wish to turn down your test execution time drastically, you can go ahead and leverage these parallelizations in order to chop down your test execution overall time by multiple folds, right? If you're running the same test using 4 parallels, that's like 1/4 of the entire test execution, right? And let's go ahead and talk about, so say for example, I have a limit for 5 parallel sessions, out of which 2 were running. But if I were to trigger tests more than 5, like for example, if my test case would have triggered 15 test cases, then 10 of them would have been into queue, and as and when the parallel counter would have nullified something out of it, my queue would have started vacating. Having said that, let's get into this build and see what kind of details we get in. So I have also triggered this test earlier, and that was that it's a pity that it failed earlier in my earlier execution. But what's really interesting is that I can go ahead and figure out where, whether my build is passed or failing, and I can go ahead and get onto the particular times frame and the slot where it failed. So if I click upon the failed scenario here, I can get into the platform and I can see why and which element failed, what was the error. And this is really interesting because what you see here is basically a video recording of the entire test session, right? What exactly is happening in the browser gets captured on the platform. And this works great as a proof of concept, because a lot of times you get into these scenarios where your QAs are not able to reproduce the bugs, and sometimes your devs are not able to reproduce the bugs. And there's always this small quarrel, I would say, that's always going on, that I'm for me it's working fine, but for the other person it's not. And that's exactly where this video recording, which is turned on by default, comes into the picture. So you have something as a proof to showcase for later on. And what's really interesting about the failure part here is that if I just select this particular timestamp, I get routed to the part where my test failed. So all of these timestamps are basically generating at every command which is getting executed, on the Selenium front. And I have different timestamps for every command over here. And I can scroll through the video and figure out what's happening. This is actually a failed scenario. So anyhow, my browser got shut. But if we were to look at a past scenario here, so I can actually see that, every Selenium command got captured, and I can pretty much go ahead and figure out any of these, pick up any of these time frames, and the timer would accordingly adjust for me to figure out what's happening inside the video there itself. Speaking of Selenium commands, you can also turn on network logs in order to capture, what's happening inside the browser's console as a part of the network logs, what activity is going across. You can also, turn on raw Selenium logs in case you want to get into the nitty gritty of it and want to deep dive further on your debugging process. If you are having anything generated on your console logs, you can check that out as well. For example, this is what I'm getting for this particular test case. And if you have passed, this is something that you have to pass separately. But in case you want to go ahead and capture your terminal logs as well, all you have to do is just pass this in your capability set, and that will happen by itself. So having said that, this is more or less about the platform on the automation front. You can, in case you come across any issue, you can create an issue directly from the automation dashboard. And this is where integrations come into the picture and help you accelerate faster. LambdaTest offers integration, as I said, with numerous project management tool. And I have Jira integrated with me right now. And what's interesting is I can pretty much go ahead and assign it to my teammate and mark it as a task, story, bug, depending upon how I want to take this forward. And I can just fill up these details as per my liking. And all of this is actually helping me avoid that route which I have to go ahead and take on Jira, depending upon which entry I have chosen. And the moment I create an issue, it will file a bug on Jira with a link for me and my team to reproduce this particular bug on the LambdaTest. And that way you're not stuck in those cluttered email chains, and you're at the same time not having the hassle of downloading these assets with you and uploading them separately on a Jira ticket, or be it on any instant communication tool, for instance, as well. In case you want to figure out all the tests that you've executed, you can deep dive into the test archives and figure out tests based upon different timeline and stamps. That way you're able to figure out pretty much which browser operating system was involved, which was the screen resolution, which timestamp, which date the test was triggered upon, what was the maximum time, and what was the average runtime of your entire tests. We have recently worked pretty hard to upgrade our analytics as well, and this is something which is ongoing as of now as well, but we give you pretty handful insights, and this is especially useful in case you're running an enterprise where a lot of browsers and operating systems are a part of your test case, and you want to have that kind of sanity check in order to figure out what's happening across browsers, right? How many browsers you're running through different browsers, how many test runs have happened, how many of them have passed, how many of them have failed, if there are any error percentage, etc. And then you can figure out what's the generic trend, how many tests are being executed across your organization. For me, I am not an active tester, but for you, if you're running tests on frequent basis, you will see this graph happen having a lot of bars over here in order to give you a clear picture as to where your testing team is moving forward, headed towards rather. Speaking of resource reutilization, as I said that you have a certain limit of parallel testing and a certain limit of queue as well. So you can figure out when was the maximum time that maximum parallel sessions breached at different timeline, right? So you are able to figure out how many tests you're running, and in case your maximum parallel count is getting flooded, you can get those kind of insights from the resource utilization. And lastly, if you have any error insights, you can get that kind of data over here as well. We also have APIs that can basically help you get all of these tests executed and extract information around these particular tests from your API folder itself. These APIs should be somewhere. Yep. So you can leverage our Selenium APIs and Cypress API over here as well in order to run your test case through an API tool. You can fetch bills, trigger bills, fetch bill details, and get pretty much details around sessions and a lot of things for here for you to deep dive in. Having said that, there's a lot to the platform. I can take forever, but I would recommend that you guys go ahead and have a look at it personally and let us know about your feedback. We work rigorously on customer feedback, and we are more than thankful to all the feedback we've received so far. It has helped us to strengthen our product immensely. And I will now stop sharing this because it's, oh, I'm so sorry. Why did I stop sharing? That's a habit. Actually, too many Slack huddles happening these days. But yes, we wanted to get back into the slides. So having said that, in case you have not already signed up onto the platform, go ahead, give it a shot, and we give you 100 automation testing minutes absolutely free with a lifetime access to the product. So by all means, go ahead and figure that out. We at LambdaTest happen to love open source. So if you're contributing to any open source program at this point of time, just let us know in the chat box, or you can drop us a query on our demo or contact page, whichever works for you. And we will enable free access for LambdaTest as well as HyperExecute, which I talked about is a unique offering about from LambdaTest that allows you to leverage cloud-based capabilities with speed as per your local test execution platform. These are the helpful links that Chris has put together, and the entire slide was run through these particular links. Chris, you want to add something to it?
Yeah, so Selenium Dev itself and the ISTQB org, basically all the information today came from these two sources. Good information, even the syllabuses on the ISTQB can give a lot of very helpful information. And obviously Selenium Dev is Selenium Dev. They are the experts in what they do.
No, except for that one URL which I passed in the chat, which talks about Lambda's blog that helps you create browser compatibility metrics. And of course, that was not part of the slide. That came impromptu. So anyways, thank you so much, Chris. This is Chris, guys. In case you want to reach out to Chris on LinkedIn, you can find him. Let me share this URL over here as well, and then we will just step into our Q&A.
I see we already got some good questions lined up.
Awesome. Can't wait to get on to that. Let me stop sharing so we can get in the Q&A over here. Cool. Chris, any particular Q&A you want to go ahead and take up first here?
Actually, yeah, there was a question by a gentleman, and I apologize if I messed this up or if I have mislabeled you. Ume Uzan, does parallelism help or hinder in cost/resources used? Example, 10 tests sequential can fail on second test. If it is a critical one, no need to test the rest before fixing the issue. Whereas in parallel runs, the other 8 would be running unnecessarily. Or can they be set up so that if one fails, make the other stop or similar? A lot of tools actually don't provide a means to do this natively. However, there is a test automation strategy that is an industry standard that can be used to do and handle this. That's actually a combinatorial of your risk-based testing combined with test filtering in pipeline executions. So an example for this is you would only run those ones which would be validating the state of your application, or build verification, or smoke testing, depending on what you call it. If those pass, validating that your application successfully runs under your default configurations, you can then test everything else. So a real common thing people will do as part of their continuous integration and continuous delivery, they'll test, for example, say Chrome or Safari, whatever their user base uses most common. And then as part of scheduled nightly executions, they'll test the rest of their browser parallelizations. That way, they already know that the current application that is stable is going to pass, or at least functionally pass those tests before they start looking for JavaScript errors.
Perfect explanation to that. Amit, in case you have any follow-up question, feel free to drop that as well. And I guess I'll take the next question. Is Jira the only app available with integration on LambdaTest front? So no, that's not it. As I said, we have numerous integrations on LambdaTest, and let me screen share that. And in fact, deep dive onto the tab which you have here on the left side, which talks about all the integrations that you can have access to. Speaking of bug tracking project or project management tools, this is the tool set that you have. Then you also have instant communication tools like Slack, Microsoft Teams, Rocket Chat, Mattermost, etc. We also integrate with CI/CD tools. And so, as Chris mentioned as well, that it's all about plugging in your CI/CD pipeline with your automation tests and accelerating it faster. So you can actually enable continuous testing by plugging your automation suites in your CI/CD pipeline and having them executed over LambdaTest using our CI/CD integrations. And then we also have codeless automation tools to integrate with, and test reporting. And of course, we are always adding to this integration set. So in case there is something that you happen to work with, but you're not finding it over here, feel free to drop us on the chat and we'll take that up. So we are available 24/7 in order to help you with pretty much anything here. So let us know in case, there's anything that we're missing out. And
looks like you got one more. 𝑯𝒂𝒓𝒔𝒉𝒊𝒕. Again, apologies if I have that incorrect. LambdaTest, can it be used for native mobile applications?
Thanks so much for routing that, Chris. Yes, Amneet, that is true. You can go ahead and do that. You can go ahead and test your mobile applications using LambdaTest as well. We do have real device cloud, as I mentioned in the slides, and you can perform manual testing, for your applications or your mobile browser testing, or you can upload your application and perform test over a variety of, iOS or Android devices. Similarly, you can deep dive into Appium as a framework and run your automation tests using that as well. So I have a test executed over here. And just like Selenium, there are logs generated for automation testing as well in order to help you debug. And just like Selenium, again, there's a recording here in order to help you pretty much with a proof of concept in case you get stuck with anything. All right, I'll stop sharing.
So it looks like that handled the question and answer section, but it does look like you have a couple that might be lingering in the chat.
Yeah, I'm just
there you want to
having
touch on?
Yes. So do we also have support for some paid testing tools like UFT, Tosca, or the current platform for only support open source tools? So Salim, we have integration list. So our integration list is not limited to open source tool. Forgive me if I'm misunderstanding the question, but you can go ahead, deep dive into the platform, just figure out all the integrations that are there. And if we are missing out on some of your favorites, let us know. We do have what I meant with, as LambdaTest loving on an open source project is that you can go ahead and refer your open source project into our program. We have an open source program, and you can route to us your case through the chat when 24/7 chat, or you can raise a ticket for that through our contact us page, and we can get back to you. And we can open pretty much free access to the platform, and even for our latest offering, which is HyperExecute, that will provide you the fastest testing experience on a cloud-based infrastructure, even in comparison to existing testing clouds out there. And is there anything else? This has been great. Chris, suggestions for the parallel testing have changed the way I'm going to write tests going forward. Thank you so much. That's from Chris Martin to Chris Wallander. And would these slides be available afterwards? Yes, these slides you can find over our YouTube channel where this video would be uploaded. We will be sharing a link to these slides shortly. Probably that's going to happen in the next 24 hours. And you can also find these slides over our social media channel. I hope that's okay with you, Chris. Would you mind sharing those insightful slides from you? Perfect.
Yeah.
So we have a thumbs up from Chris as well. So you'll be getting access to pretty much both the slides in case you want to deep dive further later on. All right. So 10x, guys, it was very interesting. Give me a lot of tips. Thank you so much. We're just glad we're able to help, Katrina. And I think we are pretty much done. It's curtains, Chris. Anything else from your end that you would want to go ahead and narrate before we give this a wrap?
No, just want to say thank you for everybody for attending. It's absolutely awesome giving this for you guys.
Yeah, big thanks to everybody who has joined us from different places from my end as well. And thank you so much, Chris, for making time out of your busy schedule. I know you have a lot to be done. Especially, I for one happen to it's just very interesting how you're managing all the collection of your cosplaying habits and the testing going all in parallel. That's some pretty unique example of parallelism out there, managing your passion and profession at the same time. But thank you so much, Chris. It was great to have you on board. And thank you so much, guys, for tuning in. And see you. Bye-bye. Happy testing.
Happy testing, folks.
All right.